So let's do a couple of examples. We'll start with a two-dimensional example in two-dimensional space. We have the xy plane, and I have 2 points. The point 2, -4, and the point 4, 4. And I want the vector starting down here and ending up here. So the vector's tail starts at 2, -4, and its head ends up here at 4, 4. Now, we have a formula for calculating the components of the vector. So let's calculate it. And this is point 1, and this is point 2. So we know the x and y of each of these points. So let's calculate the vector from point 1 to point 2. The x component of this vector is going to be x2, which is 4, minus x1, which is 2. And the y component is going to be y2, which is 4, minus y1, which is -4. So simplifying the math, this comes out to 4 minus 2, which is 2, and 4 minus -4, which is +8. So it requires 2 units in the x direction to travel from the tail to the head, and 8 units in the y direction to travel from the tail to the head. So this vector from point 1 to 2 is 2, 8. Now let's do a three-dimensional example. I have the x, y, and z axes in three-dimensional space, and I have 2 points. I have a point down here at 4, 3, 0, and a point up here at 0, 0, 7. Let's pretend that the point down here is the location of someone on the ground, and 0, 0, 7 is the location of a sniper on a rooftop. Now, if our sniper needs to aim down at the person on the ground, we'll call them the victim, then we need to know what direction that sniper needs to shoot in order to hit that victim. In other words, we need to go from up here, we'll call this point 1, to down here, we'll call this point 2. And the direction that we need is the direction of the vector, starting at point 1 and ending all the way down here at point 2. Now, we know how to calculate the components of a vector using this formula here, but that formula is for 2 dimensions. We have a 3-dimensional problem. So what we need to do is perform component-wise subtraction for x, y, and z. And the process is the same for calculating the z component of a 3-dimensional vector. So let's calculate this vector. The vector from point 1 to point 2 is x2 minus x1. x2 is 4, x1 is 0, y2 minus y1, y2 is 3, y1 is 0, and then we have z2 minus z1. z2 is 0, z1 is 7. So this simplifies down to 4 minus 0, which is 4, 3 minus 0, which is 3, and 0 minus 7, which is -7. That is the vector from point 1 to point 2. So to get from point 1 to point 2, we had to travel 4 units in the x direction, 3 units in the y direction, and -7 units in the z direction. In other words, 7 units straight down. This is how we can calculate a vector in 3 dimensions. Now let's say we'd like to calculate the opposite vector, the vector from the victim up to the sniper. In other words, what direction does the victim have to shoot in order to shoot the sniper from the ground? Well, this is a similar problem. The only difference is we now have our first point down here on the ground. That's our P1 now. And our second point is up here on the rooftop. That is now point 2. So the problem is a little bit different, but still simple enough to solve. Let's do the math. So the vector from point 1 to point 2 is going to be x2 minus x1, 0 minus 4, which is -4, y2 minus y1, 0 minus 3, which is -3, and z2 minus z1, or 7 minus 0, which is positive 7. Now, I want you to notice the difference between the two solutions to these two problems. Remember, this was the vector we calculated when we wanted to know the direction from the sniper down to the victim. And this new vector is from the victim up to the sniper. Now notice that the x, y, z components numerically are the same, but the signs are opposite. The vector from the sniper to the victim has positive 4 and positive 3 for x and y, but negative 7 for the z. And the vector from the victim up to the sniper is negative 4, negative 3 for x and y, but positive 7 for the z. So the numerical values are the same, but the sign is the opposite for each respective component. And this is a quality for opposite vectors. You can take any vector pointing in one direction and obtain the exact opposite vector, the same magnitude pointing in the exact opposite direction, by flipping the sign of its x, y, z components. So now we understand a very important characteristic of opposite vectors. So now that we've calculated a couple of examples by hand, let's do some examples in the engine.